A young bald eagle lifts off from a cactus in the Arizona desert, and instead of doing what every textbook says it should do, it turns north, not south, toward warmer weather, not toward Mexico, like nearly every other migratory bird in North America, north, straight toward Canada, in the middle of summer. Every field guide, every wildlife documentary, every basic lesson about bird migration teaches the same rule. When the season changes, birds fly south to escape the cold and find food. It's one of the most repeated facts in all of nature, and these eagles broke it completely. Scientists strapped GPS trackers to dozens of these birds, expecting to confirm what everyone already assumed. Instead, they found eagle after eagle doing the exact opposite of what an eagle is supposed to do, flying toward colder places during the warmest part of the year, for reasons nobody could immediately explain. One researcher, looking at the data for the first time, said it made her question things she thought were basic, settled science. Today, we're going inside one of the strangest migration mysteries ever recorded in America's national bird, and the discovery that's forcing scientists to rewrite what they thought they knew. To understand why this discovery is so strange, you have to understand the rule it broke. For most of North America, bird migration follows an incredibly consistent pattern. As temperatures drop in the fall, birds head south, toward warmer climates, toward food sources that haven't disappeared under snow and ice. Then, as spring arrives and temperatures rise again, they fly back north to breed, taking advantage of the long days and abundant food that summer provides. This pattern is so consistent, so universal across species, that scientists built entire models of animal behavior around it. Geese do it, songbirds do it, the vast majority of raptors, birds of prey like hawks and falcons, do it too. Bald eagles were assumed to follow the same basic logic. Breeding pairs in the northern United States and Canada fly south for winter, then return north each spring to nest, exactly as expected. But not every bald eagle in America is a breeding adult sitting on a fixed nest. Thousands of young eagles, and adults not currently breeding, spend years wandering before settling down, and almost nobody had closely studied what those specific eagles were actually doing. Between 2017 and 2023, a research team studying bald eagles in Arizona set out to answer a fairly basic question. Where do the state's non-breeding eagles actually go? Led by researcher Dr. Caroline Capello, the team attached satellite transmitters to 24 young eagles, along with 2 non-breeding adults, and tracked their movements continuously for years. The goal wasn't to overturn migration science. It was simply to fill in a gap. Arizona's breeding eagles were already well understood. The non-breeders were basically a blank spot on the map. What the tracking data revealed instead was something the team hadn't expected at all. Arizona's bald eagles begin their breeding season in winter, an unusual timing already, driven by the state's desert climate. Once that breeding period ends, as spring turns into summer, these eagles don't fly south like almost every other migratory bird in the country. They fly north, deep into southern Canada and the northern United States. Some individual eagles traveled well over 1,000 miles, tracing consistent routes through states like Utah and Idaho, or cutting through Nevada toward the Pacific Northwest. Then, as autumn approached and virtually every other migratory bird in North America was already heading south, these same eagles turned around and flew back to Arizona, just in time for their next winter breeding season to begin. The researchers now faced the real puzzle, not just documenting the strange direction, explaining why any bird would evolve to do this on purpose. The leading explanation comes down to one simple resource: food. During the summer months, when Arizona's brutal desert heat makes hunting and survival more difficult, regions to the north are entering their most productive season of the entire year. Salmon runs are active in northern rivers. Waterfowl are nesting in massive numbers across northern lakes and wetlands. Carrion, the dead and dying animals eagles rely on for easy meals, becomes significantly more abundant across these cooler, resource-rich landscapes. In other words, while most birds are fleeing the cold, these eagles are following an entirely different signal. Not temperature, opportunity. The study found that many of these young eagles didn't fly in a straight line to one destination and stay there. Instead, they move between multiple stopover sites, often the same historic lakes and rivers used repeatedly across different years, behaving less like birds fleeing weather and more like opportunistic travelers chasing whatever region currently offered the richest food. Researchers describe this as something closer to strategic wandering than traditional migration, not a fixed journey from point A to point B, a flexible, food-driven loop across an enormous stretch of the continent. But this unusual behavior comes with a serious cost that researchers didn't initially anticipate, because these eagles are following food rather than a single predictable route, and because their journeys stretch across so many different states and habitats, they encounter a wide range of human-made dangers along the way. Electrocution from power lines remains one of the most significant threats to large raptors like bald eagles, and these long-distance wanderers cross an enormous number of power infrastructure corridors during their travels. Poisoning from lead ammunition fragments in scavenged carcasses poses another serious risk, especially given how much of their diet during these journeys depends on carrion. One of the specific eagles tracked in this very study was later found to have died from electrocution, a stark, direct reminder that this remarkable, food-driven journey isn't just scientifically fascinating, it's genuinely dangerous every single time these birds attempt it. Researchers noted that as these eagles grow older, their flight paths tend to become noticeably more precise and efficient, relying heavily on the same specific stopover locations they successfully used in previous years, suggesting that surviving this journey, especially in the earliest attempts, may itself function as a harsh filter. The eagles that make it through and learn the safest, most efficient routes are the ones most likely to keep surviving it in the years that follow. If this discovery is surprising you as much as it surprised the researchers, do me a favor and hit that like button right now. It genuinely helps stories like this reach more people who'd find it just as fascinating. Here's what makes this discovery matter far beyond just one population of eagles in Arizona. For decades, scientists have treated bird migration as a relatively simple, temperature-driven behavior. Cold pushes birds south, warmth pulls them back north. It's one of the most fundamental assumptions in the entire field. These Arizona eagles demonstrate that migration can be driven by something far more flexible and complex than temperature alone. Not every population follows the same rule. Not every individual bird behaves the way its species is broadly assumed to behave. Researchers are now questioning how many other bird populations might display similarly unexpected patterns that have simply never been closely tracked. Non-breeding individuals, juveniles, and wandering adults across many species have historically received far less research attention than breeding pairs sitting on well-documented nests, which means this discovery may not be an isolated oddity. It may be a signal that science has been missing an entire layer of bird behavior all along, simply because nobody thought to look closely enough at the birds that don't fit the expected pattern. This discovery isn't just reshaping scientific theory. It's already reshaping how conservationists think about protecting these birds.